In this session, we'll be discussing problems on Z parameters. I have a question. Test results for a two-port network are A. First set I1 is equal to 0.1 angle 0 degree ampere, V1 is equal to 5.2 angle 50 degree voltage, and V2 is equal to 4. This is V2. V2 is equal to 4.1 angle minus 25 degree volt with port 2 open circuited. And in B, it is given I2, V1 and V2 with the port 1 open circuited. Here, find Z parameter. Here we have to find the Z parameter using these values. Z parameter means we should find Z11, Z12, Z21 and Z22. Okay, so in A part we have got the values of I1, V1 and V2 when port 2 is open circuited. That is when the output port is open circuited. When output port is open circuited, we will get Z11 and Z21. Z11 is equal to, we have already learned, V1 by I1 at I2 is equal to 0. Okay, so before that let me write the equations of Z parameter. V1 is equal to Z11 I1, Z11 I1 plus Z12 I2. I have written the equations. From this we can write these easily. So we have got Z11 is equal to V1 by I1 at I2 is equal to 0. And from the equations we can see Z21 is equal to V2 by I1 at I2 is equal to 0. Okay. So from the values given here, it is given, the values are given with port 2 open circuited. Okay, so the values V1 is equal to 5.2 angle 50 degree. 5.2 angle 50 degree divided by I1, that is 0.1 angle 0 degree. So we will have 52 angle 50 degree. Okay. So now coming to Z21, we have V2 by I1 at I2 is equal to 0. So we can take V2. V2 is equal to 4.1 angle minus 25 degree divided by I1 is again 0.1 angle 0 degree. So here again we have, so dividing this we have 41 angle minus 25 degree ohm. Okay. This is impedance parameter, so we can write the unit as ohm. So here we got Z21. Next, we have the I1, V1 and V2 with port 1 open circuited. That is with input port open circuited. Secondly, when port 1 is open circuited, that is when input port is open circuited. Here we have the equations. When input port is open circuited, that is I1 goes to 0. So we will get Z12 and Z22. Z12 is equal to V1 by I2 and Z22 is equal to V2 by I2. So we can write these two equations. We have Z12 is equal to V1 by I2 at I1 is equal to 0, and Z22 is equal to V2 by I2 at I1 is equal to 0. Okay, so now we have the values in the part B as in the question. V1 is given as 3.1 angle minus 80 degree. 3.1 angle minus 80 degree. And I2 is given as 0.1 angle 0 degree. So here we have 31 angle minus 80 degree ohm is Z12. And here V2 is given as 4.2 angle 60 degree volt and I2 is given as 0.1 angle 0 degree. That is 42. 42 angle 60 degree ohm. So now we have found Z11, Z12, Z21 and Z22. This is the answer to the question. Earlier we saw a direct question. So here we have a circuit. Find the Z parameter for the network shown in the figure. So here we have to apply KVL. So let's take the two meshes. Mesh 1. Let the current be I1. And here current is flowing like this. So let's take it in this direction. Okay, it's better to take the directions like this, so you can will get the answers in a better way. Okay, so let's consider mesh 1. KVL in mesh 1. KVL in mesh 1. So we can write V1 minus Z1 I1 minus Z2 into I1 plus I2 is equal to 0. So now, the Z parameter equations were V1 is equal to Z11 I1 plus, I have written the basic equations of Z parameter. So now we have written the equation of mesh 1. Now we have to bring this equation to this form. Okay, that is, we have to group together the coefficients of I1 and I2 together, so that we will get Z11 and Z12 from the equation. So let's write that V1 is equal to I1 terms. Okay, when we bring this side, the minus term will go to plus Z1 plus Z2. Okay, this is Z2. And now coefficients of I2. I2, the coefficient is Z2 alone. So this is equation number 1. So from this we will get Z11 and Z12. Okay. Now let's write KVL in mesh 1, mesh 2. V2 minus Z3 into I2 minus Z2 into I2 plus I1 is equal to 0. So now this is we have to bring this to this format. We have to bring this equation to this format. So we can write it like V2 is equal to, first terms of I1 into Z2 plus I2 into Z3 plus Z2. This is equation number 2. So from these two equations, equation 1 and 2, on comparing it with these equation, you will get Z11 as Z1 plus Z2, Z12 is equal to Z2, Z21 is equal to Z2, and Z22 is equal to Z3 plus Z2. Okay, so now we can write it in the matrix form. Z parameter is equal to Z11, Z12, Z21 and Z22 is equal to Z1 plus Z2, Z2, Z2 and Z3 plus Z2. So this is the answer to the question. And also one more thing you should keep in mind, if you get such a problem with the resistors in these three corresponding positions, that is a T position, a T like section, you can and the Z1, Z2 and Z3 are given like this. Then you can find the Z parameter as Z1 plus Z2 is Z11, and Z21 is equal to Z12 is equal to Z2, and Z22 is equal to Z3 plus Z2. That is, the sum of these two resistors is Z11. Z21 and Z22 is Z21 and Z12 will be Z2 itself, and Z22 is equal to Z3 plus Z2. That is the sum of these two resistors. Z11 will be given by the sum of these two resistors. Sometimes in a problem you will get it like sometimes Z1, Z2 and Z3. So you should know the positions of these resistors. So the sum of these two resistors will give you Z11. The sum of these two resistors will give you Z22, and Z21 and Z12 will be given by Z2, this resistor. Okay, that's all about this problem. Thank you. I will take the next session, the rest in the next session.